Hey everyone, welcome back. In today's video, we're going to talk about CRAM files. Let's get started. So what is a CRAM file? It's a file format for storing sequence alignment information, and it typically uses the .cram file extension. And if you're thinking this sounds a lot like SAM/BAM files, you're right. Indeed, both BAM and CRAM files store sequence alignment information, but they do so in very different ways. BAM files compress blocks of data, while CRAM files compress columns of data using different compression algorithms specific to the data type being compressed, and this yields several benefits. The first is reduced storage size. In fact, CRAM files can achieve between 40 to 70% better compression than BAM files, depending on the data being compressed. The second benefit is cost savings. Since CRAM files save space, that means less money is needed to purchase hard drives if managing a local or HPC computing environment. And less money is needed to pay for cloud storage costs if using a commercial cloud provider like Amazon AWS. And for large projects, this can lead to significant cost savings. And I'll show a real-world example of this at the end of the video. However, there are several drawbacks with CRAM files as well. First, converting a BAM to a CRAM file takes time. The amount of data that can be compressed varies between 3 to 9 gigabytes per minute, depending on the number of CPUs you have access to. And this can add up if you have many large files to compress. Second, CRAM files require the original reference genome in order to decompress the data back into a BAM file. And I'm sure we can all see a potential problem with this. Imagine you're a graduate student and your PI asks you to recover some archived CRAM files, but the original graduate student or postdoc who compressed them is long gone and didn't leave you with any documentation on which reference genome was used. In this case, you might be in trouble. Third is tool incompatibility. Many tools can accept BAM files as input, but not CRAM files. So the CRAM file might need to be converted back into a BAM file before it can be used again. Let's actually read a quote from the GATK tools documentation. If you're not familiar with GATK, it's a popular software tool for performing variant analysis, identifying single base substitutions and indels. So here's the quote. All GATK tools that take in map to read data expect a BAM file as primary format. Some support the CRAM format, but we have observed performance issues when working directly from CRAM files. So in our own work, we convert CRAM to BAM first, and we only use CRAM for archival purposes. And I think the main takeaway from this is that you should use BAM files for downstream analysis and CRAM files for long-term data storage and archiving. Now let's look at a real-world example from the Emirati Genome program. The primary objective of this national initiative is to sequence the genomes of 1 million UAE citizens. The project was expected to generate 10 petabytes of BAM files, which would then need to be stored on a commercial cloud platform. But they are instead converting the BAM files to CRAM files and reducing their storage requirements to 4 petabytes, which is saving them $1.2 million in annual storage costs. That's it for this video. In the next video, we'll talk about VCF files. I'll see you there.